Yeah, so we started the recording for today's class, which is a continuation of the Kinematics Momentum P2 worksheet paper to solving. We discussed this graph in our last class, and then we're going to move on forward from here. So yeah, keep them coming. Problems. Question number 8. Anyone problem with question number 8? 8, 9. 10. 11. I think 11.
Sir, 10.
10. হ্যাঁ 10 এর কোনটা সমস্যা বলো?
NC2RD.
আচ্ছা 10 এ তোমাদের কিছু let me tell you some calculation factors for question number 10, which would be helpful for you to do that calculation. And in the moment, I mean, any type of collision has to do with momentum change, which also include nuclear collisions as well. So whenever nuclear collisions will happen, for example, in this case, a certain francium nucleus is decaying into two parts. One is the asteroid nucleus and another one is the alpha particle, and they are shooting themselves in opposite direction. So they're gonna have equal momentum change. The basic idea that we define as explosion, where one object breaks up into multiple pieces, which in this case is two pieces. So so this is also possible for us to work with. Now the baseline to work with this for this kind of situation while you are using the we are using the while we are using the law of conservation of linear momentum. Law of conservation of linear momentum. The problem usually is the mass. Now the mass is pretty simple to work with. We can measure, not measure essentially, we can use the mass amount of the individual atoms, which can be expressed as a multiple of atomic mass unit. Do you guys know what atomic mass unit is? From your chemistry, maybe? Not from your physics. It wasn't taught in your physics syllabus yet. But do you remember? Do you know what is atomic mass unit from your chemistry?
Gram per mole.
No. You definitely know this name, but maybe maybe you don't know this by this name. Yeah, কি বলছো? ইফাত কি বলছো?
স্যার ওই যে রিলেটিভ অ্যাটমিক মাস
রিলেটিভ অ্যাটমিক মাস, এক্স্যাক্টলি। রিলেটিভ অ্যাটমিক মাসটা হতো ডিফারেন্ট ম্যাটেরিয়ালের জন্য ডিফারেন্ট হয়, বাট I mean, what is your standard to find out the relative atomic mass? I mean, what do we compare with to find out the relative atomic mass of something?
Carbon 12 atom.
Yes, that's half the information. What of the carbon 12 atom?
112
Yes, exactly. So এখন ঠিক আছে. So that much mass, 1/12 of one carbon 12 atom. Every part of this phrase is important. 1/12 important of one important, carbon 12 isotope important, atom not nucleus important. So 1/12 of one carbon 12 atom is something that we have considered, that the scientists have defined to be the standard of atomic mass measurement. So that's what we use for all sorts of measurement over here. And every single other atom other than carbon, so in this scale, one carbon 12 atom has an atomic mass of exactly 12, or atomic mass unit of exactly 12. Now this 12 does not mean 12 kg. This 12 is represented as 12U, small u, that is. So I've been trying to use my right pad since yesterday. We tried the whiteboard over here and it's all messed up. So we use U, and the way it works is this. So the mass of one carbon 12 atom equals to 12U. Here the U is defined as atomic mass unit, which has a value of 1.66 into 10 to the power minus 27 kg. You don't have to memorize this value, This will be this is not n, this is u. This will be given to you in the formula sheet, so you don't have to bother to memorize this number. This will be given to you in the formula sheet. So in the same mechanism, you can find out the mass of other relevant objects as long as you can find out, sort out their mass number, not atomic number. In the equation that we gave, the breakdown was that we had a stationary acetylene, we had a stationary what nucleus? Francium nucleus, Fr into acetylene. Okay, so a Francium nucleus was defined to have a mass of 208. It does not necessarily give us the atomic number, which we do not need for this sum. So the mass number of the francium 20 was 208. So I can very well write that লিখা পড়া না গেলে বলো। এই হচ্ছে আমাদের mass number basis division. Now, if we did know the atomic number over here, we could have we would have been able to write all the other lower number as well. But since I only know the mass number, so I wrote the mass numbers in bracket on the right side, not by the typical formation that we go for. For example, upper left corner holds, for the upper left corner holds the mass number, and the lower left corner of the symbol holds the atomic number. I don't have those information, so I wrote it in this format. Do you understand what this equation is about? Everyone?
Yes, sir.
Can you please raise the volume of your voice? Okay. Is it better now, Adhara? Can you hear me better now? Hello? Okay. I just didn't do anything. I just raised up the microphone closer to my mouth. That's the best I can do. Anyway, so the point that I was trying to make is that whenever you will be doing math with this problem, francium nucleus will have a mass of 208 U. Acetylene nucleus will have a mass of 204 U. So what if you know the mass number of a certain atom, you can simply multiply the U amount with this thing over here. Helium nucleus will have a mass of 4 U. Interesting for you to observe that whenever you'll be doing your sum, you don't, preferably for the momentum sum specifically, you do not prefer to multiply this whole number with your necessary mass numbers to get the actual mass in some scientific format, because the way our momentum equations always work is that if I write my own equation for over here, let's say in this case it is going to be m1 plus m2, initial velocity is 0, equals to m1 v1 plus m2 v2. Now think about it. If you place all of these masses in terms of u, you can very easily cut off all the u's from all sides. You don't have to even bother to place that value. But when you're writing the equation in the first place, you have to write the u values so that the examiners would know that you know what you're doing. Was this the confusion problem? বুঝা গেছে কি আলাপ করলাম? বলো।
Yes, sir.
আচ্ছা। So this was that. So এখান থেকে বাকি সব কাজগুলো easily করে ফেলতে পারবা. So if you want to know the mass amount, rest of the part should follow pretty simply. Anything else from this question number? I think D number is a problem. Achha, there was a bit of repetition for the D number question, right?
Yes, sir.
This is D1.
D is only one hot question.
This is C2 and D. C2 and D somehow got repeated twice. So can I delete this? I cannot delete this. Why can I not delete this? Achha. I'll have to delete it from elsewhere. Never mind. So close examination of the decay of the Francium nucleus indicates that the asteroid nucleus and the alpha particle are not ejected exactly in opposite directions. Suggest and explain for this observation. So this is the another question that you have to consider very minorly for the case of the linear conservation of momentum. The whole point of linear conservation of momentum means that the total momentum of the setup or the system before collision should be equal to the total momentum of the system after collision. As per this question, before collision, before the breakdown, the Francium nucleus was remaining stationary. This was altogether stationary, and then it breaks down and it produces two pieces, asteroid nucleus and the alpha particle. Now, important for you to understand that because the initial particle was stationary, which means the total momentum stored in that particle was zero. Now it is going to break down into asteroid nucleus and alpha particle. So if we calculate their momentum altogether as vector quantities, the vector sum of the momentum of asteroid nucleus and the alpha particle, their vector sum of momentum should also become zero. But this question says, the question already specifies, close examination of the decay of the Francium nucleus indicates that the asteroid nucleus and alpha particle are not ejected exactly in opposite directions. This is a very important thing that you need to understand. If you want to vector sum two vector quantities and want to get a perfect zero value out of it, it is imperative that these two vectors have to be equal in opposite direction. They have to be equal in magnitude and they have to be working in exactly opposite direction. Only then can you add these up and get a zero. Because if there is even a small bit of angle variation, think about it. Let's say if I just try to show you something over here. Let's say one vector is working this direction, and the vector is supposed to work the opposite direction. But let's say it made you a very slight bit of angle like that. To be honest, you cannot add these up to get a perfect zero because there is a bit of an angle between them. They are not perfectly opposite. You will end up with a very small, maybe a very small parallelogram, and that parallelogram might give you the resultant of these two. So the vector sum of these two these quantities might not as well be zero, but logic tells us it is supposed to be zero. Do you get the problem here? That, I mean, what does the physical information that they are not ejected directly in opposite direction, what does this physically employ? দেখো কথা বুঝা যাচ্ছে কিনা? So for the collision to be logically acceptable, these two particles which were ejected out of the breakdown process, they have to work in perfectly opposite direction. They are supposed to, but the question already specified that close examination proves that they're not working in perfect opposite direction. Then how could we possibly approach this for the next part? That answer happens to be pretty simple. That answer is that there must be a third particle involved. If you wonder how could there possibly be a third particle involved, have a look. Let's say this is the momentum of the asteroid nucleus. Let's say this is the momentum of the asteroid nucleus. Let me just write Ctrl Z. Let's say this is the momentum of the asteroid nucleus. Let's say this was the momentum of the alpha particle. Now you can see over here that there is this much momentum remaining. So if you want to get rid of this, maybe it's possible that if we did have another third particle involved, which had a momentum of this much, then the vector sum of all of these three quantities can give you zero. So that is very much possible. But the reason they are specifying us this information is because that this kind of observation are actually the ground of discovering a lot of subatomic particles which are extremely small. For example, neutrinos and such. Because whenever as time went by for the scientific research processes for nuclear physics, our observation mechanisms became more and more precise. They could detect even smaller and smaller particles. The reason scientists strived towards this effort, because they knew that principle of conservation of momentum is supposed to be held constant. But when they did measure the available particles perfectly in their alignment, they found out that they were not working in the same direction, which essentially proved that there has to be some other particle involved, which with our current mechanism of observation, we are not being able to observe. So they knew that they would have to go ahead and improve their equipments for more smaller particle detection. And that eventually started the process. Do I make sense? You don't have to essentially know this historical background. I'm giving you some historical background so that it's easier for you to remember, because stories actually work with our brain pretty well. So close examination of the decay of the functional nucleus indicates that the asteroid nucleus and the alpha particle are not ejected exactly in opposite directions. So it's an explanation for this observation. So what do you think would be an explanation for this observation? There must be a second particle involved. Let's have a look at the mark scheme. কত নম্বর ছিল? Number 10. তোমাদের লিংকটা আমি জুমে শেয়ার করছিলাম না?
কিসের লিংক স্যার?
এই ক্লাসের লিংক কোথায় আছে? ইনভাইট থেকে কপি করা যাবে তাই না? Copy invitation. Because Aisha was trying to enter and she did something exactly আমি এখানে কেন ঢুকলাম? Why did I come here? Oh, sorry. এই দেখতেছিলাম। My bad. আচ্ছা হ্যাঁ, ব্রাউজারে ঢুকছিলাম হচ্ছে আশাকে লিংক শেয়ার করার জন্য। ঠিক আছে। Have a look. D number. And the particle slash photon is emitted or at an angle to the direction of the alpha particle. At an angle to the direction of the alpha particle. This means one thing. I mean, this second point is important for one aspect is that this second particle this third particle that we are trying to determine or trying to talk about, which is supposed to be there, this cannot exist in the same direction as the alpha particle, because if that's the case, then you cannot get a resultant momentum sum zero. To have a total momentum zero after collision, this particle has to make some angle with the direction of the alpha particle, so that you can make a resultant of these two eventually. So that let's say if you make a resultant of the alpha particle and of the unknown particle, let's say I'm going to label this as p unknown, momentum of the unknown. So do right pedal I have কষ্ট আছে. It's not as easy as I thought it would be. You need to have really good hand controls or such. So you want to have the unknown particles momentum in such a direction, so that whenever you actually make a resultant out of these two, let's say if I make the resultant of the unknown particles momentum, let's say pu unknown, whenever we will make the momentum of the resultant momentum of the unknown particle and the alpha particle together, this thing should be equal to the momentum of the apparent particle. So it's important that there must exist a certain angle between these two directions. Without having these two angles properly, we cannot make that thing to happen. That's why they have mentioned that angle thing or that angle information for one additional mark in the mark scheme. Take a look. This is the one. Another particle or photon is emitted at an angle to the direction of the alpha particle. Okay. Anaf Islam, what seems to be the problem? Leave the আবার join করো, সমস্যা নাই. Is he seeing the chat? Bhaktiar, if you are making weird sounds of ice and everything and glasses, you can mute your channel and do that. It's better for all of us.
স্যার আমি তো মিউটই ছিলাম।
আর তোমার voice sensitivity দিয়ে unmute করার option activate করা, so every single time you're making some sound around your device, your computer is automatically unmuting you, and we are hearing those sounds. I could tell
Sir, at an angle to the alpha particle, তারপর বিষয়টা
হ্যাঁ বুঝাবো
at an angle to the direction of the alpha particle মানে আবার বুঝাই দেবে।
this means that the unknown particle that is that we are presuming or the third particle that we are presuming to be involved in this process, that particle cannot have the momentum in the same direction as the alpha particle. Try to think about it. If you have, let's say these two are not exited in the same direction, and let's say if you assume that one of these things let's say asteroid nucleus is going this way and the alpha particle was going slightly this way, and let's say the unknown particle was also going in that exact same way. If that is the case, then you can never make the resultant of these three vectors zero. Because try to get the basic idea for how can we make three vectors to become zero, which I was supposed to teach you in the fourth chapter, but might as well talk about this here, no big deal. Is that you can essentially make the resultant vector of three vectors zero only if they are working in three different directions, or in more accurate terms, the resultant of any of those two is perfectly cancels out the third. মানে হচ্ছে আমি মনে করি একটা ভেক্টর ইকুয়েশন লিখতেছি এখানে, দেখো মনে করো a plus b plus c equals to 0. So let's say this is a vector equation. This would essentially mean, this can mean a lot of specific information for us. For example, I can write from here that a plus b equals to minus c. Can I not write this?
Yes, sir.
Or I can write a plus c equals to minus b. Or I can write b plus c equals to minus a. What am I trying to show you? I'm trying to show you that if you have the vector sum of any of the two vectors involved in a three vector situation, the resultant of any of the two vectors must be equal and opposite of the third vector, so that whenever you will add those two vectors, for example, let's say you have three vectors involved in a certain scenario, and you do the resultant of these two, this is supposed to logically become minus c. And whenever you will do c plus minus c and plus c in a second step, so let's say this is step number 1, triangle rule or parallelogram rule, then this is step number 2, triangle rule or parallelogram rule, you can eventually get 0. If you have to get 0, then the sum of any of these two should be equal and opposite to the third one. That's the only way you can make that resultant of three vectors 0. So that's what they're saying over here, that it is impossible or it is unacceptable that this unknown particle that the third particle that we're talking about, this must come out with some angle with the alpha particle. This must not be in the same element with the alpha particle, because if it is in the same element with the alpha particle, I mean, the sum of these two particles would still work in that same exact direction. Just it's going to be slightly bigger because there is an angle between them. You're just going to make them addition. These two, but the resultant of this one and this ascending particle momentum, that cannot give you a resultant 0. But it is supposed to be 0 because by definition, as from the question, the Francium nucleus before the collision was stationary. বুঝতে পারছি?
মার্সিমে তো শুধু বলেছে যে at an angle to the alpha particle, বাট কোন সাইডে কাজ করছে সেটা তো বলে নাই। তাহলে যদি মানে রেজাল্টেন্টের দিকেই কাজ করে তাহলে তো আর 0 হবে না, তাহলে ওটা স্পেসিফাই করা লাগবে না।
এখন they have given you 2 marks for this question, and they wanted that equation, that information out of the case for your comfort zone. I totally get your questions, Zarif, what you are trying to imply here, but you would not know the mark scheme in the exam. So how would you write the answer to know in your brain that you are going to score full marks? That's the question, right?
Yes.
Very much. So if I was writing this answer, I would prepare myself with an answer statement that might sound somewhat like this: that this particle produces some angle with the direction of alpha particle and also asteroid nucleus, such that the resultant momentum of all of these three particles together is 0. I would add this last information additionally, which we might find out in the examiner's report. I mean, I might not be creating this out of thin air. Have a look at the examiner's report. Very few candidates suggested that simultaneous emission of another particle of our gamma ray photon. Instead, very few suggested that. Instead, many suggestions were based on either electrostatic repulsion between the asteroid nucleus and the alpha particle, or the influence in some way or of the Francium nucleus. So actually, the involvement of a third particle was missed out for most of us. So the examiner's report doesn't say anything about that. So to be sure about to make me score this second mark, I would write that. The alpha particle produces an angle with both asteroid nucleus and the alpha particle, such that their vector sum of all the three particles, the vector sum of the momentum of all the three particles is 0. I would go ahead and further this information that way, because that basically is what we are going after, right? বুঝতে পারছি?
জি স্যার।
Beautiful. আচ্ছা, এটা গেল। তারপর সাদিয়া বুঝা গেছে?
Yes, sir.
আচ্ছা, 11 কোনো প্রবলেম? Anyone? 11 or দেখো তুই কোথাও আটকাইছো? 12
স্যার এগুলো মার্ক স্কিম দেওয়া আছে না?
এই যে এখানে সবগুলো মার্কস সব দেওয়া আছে।
Sir, 11D2.
ওকে, 11 D2 can be we can work out. আচ্ছা, D1 বন্ধ করে আসতে পারছো, রাইট? A2 বন্ধ মেক সেন্স করছে, রাইট?
Yes, sir.
আচ্ছা, so let's have a look over here. আচ্ছা, আমি একটু কোশ্চেনটার অ্যাসপেক্টটা বলে আসি। There is a girl who is maintaining her speed at 3.5 meter per second uniform speed, and there is a boy who is supposed to start from 0, accelerate to a much higher speed, and then eventually the boy will catch up with the girl. So the way this mechanism works is that if you want to physically visualize this, the boy was standing at a certain position, and then the girl is coming over here at 3.5 meter per second uniform speed. The instance the girl becomes aligned with the boy, the girl keeps on moving at 3.5 meter per second because she has some earlier speed from earlier, and this is the instant where the boy starts to move. So that is how t equals to 0. So they both start from the same initial displacement 0. And as time goes by, she keeps on moving at uniform speed or uniform velocity, however you put this. But this kid is going to accelerate for a certain duration, and then this kid is going to maintain an uniform speed as per this paragraph defines over here, and eventually this boy would be able to catch up with the girl. So that's the basic idea of this whole question. Now in D now it says the boy and the bicycle have a combined mass of 667 kg. Calculate the force required to cause the acceleration to the boy. You can find this out very easily if he goes to MA. Then comes the question: at the speed of 4.5 meter per second, the total resistive force acting on the boy and the bicycle is 23 Newton. Determine the output power of the boy's legs at this speed. Now let me put this very simply. There is a simple formula for power which is given by force into velocity. Do you guys know this formula? That power of a mechanical system can be also written in this format. Have you seen this formula before?
Yes, sir.
Achha, for those of you who haven't, let me help you out. Power equals to work done over T. We know this equation definitely, right? All of us. Now, work done can be written as what? Force into distance divided by T. If I segregate the force over here, I can write D over T, which can be written as velocity expression. So why is this important? Or in which cases this is important? This is the case of the power for a scenario where, try to listen up to this next part very carefully. If you want to maintain the uniform speed v of an object, you need to continuously provide a force on the object. Or in other terms, I can say, as the object is moving, the total resistive force on the object opposite to the velocity is F. So to maintain that uniform velocity, you need to continuously push the object in the forward direction by speed of F, by force of F. So one practical example that I can tell you is that, let's say there is a car that is moving in the road. There is friction between its internal components, and there is the air resistance. So you cannot essentially speed up the car to a very high value. If you press down your accelerator, the car is going to speed up depending upon the engine capability and the mass that the car has, and it will speed up, and eventually at one point this is not going to speed up anymore. The point where the speeding up will stop is basically where the total forward force produced by the engine and the tire and the road friction would become perfectly balanced out by the reverse force of the air resistance. At this point, the car will reach its limit. if you want to maintain that speed further on, you have to keep your accelerator pressed. You have to continuously produce this forward force to continuously overcome this backward force, air resistance, so that the resultant of these two forces becomes zero and you can maintain the uniform velocity. So to maintain that uniform velocity, you have to continuously provide that force. How much is the power for this kind of scenarios? That how much energy is being used for this kind of scenarios is basically what we can calculate from this formula. So this formula is exclusively applicable for cases where we are trying to maintain a uniform speed of the object, and to maintain that we are applying a fixed amount of force. First, before you go, I mean, you're simply going to use this formula to do the calculation, but do you understand the meaning of this whole thing? এই কোশ্চেনটার ইমপ্লিকেশনটা কি বুঝে যাচ্ছে কিনা প্রমাণ দেখো? So how am I going to use this equation for my purpose over here? The question reads that at the speed of this much, the total resistive force acting on the body this much, determine the output power of the boys like at this speed. So you're simply going to multiply these two numbers and you are going to find out the power, output power. Now, if I want to give you a physical view of this thing, try to understand. The boy have to produce out of his leg a forward force. Let's say this is the boy and the bicycle. So this is boy plus bicycle. So the backward force on the boy and the bicycle is 23 Newton. To maintain his uniform speed for in the forward direction, he has to also produce 23 Newton as well. And as per the question, the speed of the boy is how much? 4.5 meter per second. So within a duration of 1 second, how much is this whole thing is going to move forward? How much would be the displacement in 1 second? How much he's going to move forward? 3.5 meter. Think about this. So how much would be the total work done by this kid? That would be force into displacement. This much is the total work done in 1 second. And if you do the division of force into displacement divided by time, you basically get the power. So that's basically what we're doing over here. Total work done in 1 second divided by 1 second. Or in other terms, I can simply say we are multiplying force into velocity, which also perfectly makes sense.
The boy is also accelerating, right?
No, the kid is not accelerating. The bicycle is not accelerating because he is trying to maintain a uniform speed of 3.5 meters per second. To maintain that, he has to continuously provide the equal force to overcome the resistive forces. So he is continuously applying the force, but he's not accelerating anymore because those force is being eaten up or cancelled out by the opposing forces of resistive forces.
Sir, the question says the girl travels at a constant velocity of 3.5 meters per second, but the boy accelerates until he's at speed 5.6 meters per second.
Did I mess it up? Oh, I did mess it up. Oh, acha. So my bad. If you calculate, in that case, if you calculate this value, this would be the instantaneous power of the boy at that point of time where the boy was moving at 3.5 meters per second. So as per the question, okay, let me just go further. The girl moves with the velocity of the girl is 3.5 meters per second constant, right? And then the velocity of the boy is defined something like that. He started from 0, went from 0 to 5.6 within a duration of how much? How much is the time over here? 5 seconds? I think 5 seconds. He accelerated from 0 to 5.6 in 5 seconds, and then he maintained in the 5.6 meters per second. Okay, so the instantaneous power of the boy at when his speed was 3.5 meters per second would also be the product of these two things. But it should be more. Shouldn't it be more? It should be more. Why should it be more? Because when the boy was at 3.5 meters per second, he didn't stop. He was accelerating. So all this calculation that I showed is not full. This is not complete. Achha, I really actually did not read the question properly, and that's why I was giving you this wrong information. So I'll tell you what is happening. Have a look. In this case, in this case, the question says that the force required to cause the acceleration of the boy is something. This is the required force to make the acceleration, and also there would be a backward force of 23 Newton. So okay, fine. I'll show you this process once again. So have a look at a different scenario. I'll keep this observation over here so that we have a reference. I'll use this with a different color. let's say here is the boy and the bicycle. Here's your object. The total resistive force working on the object is 23 Newton. You need to overcome this force and also make an acceleration, which you did calculate in D1. So let's say this is our forward force. Let's say I'm going to write this as F, force in the forward direction. The idea is that the resultant force should be equals to MA, who should come from forward force minus 23 Newton. See if it makes sense. The resultant force should be an output of all the available forces on the system. I'm getting further down the point over here. This would be the case if the boy was moving at a constant speed of 3.5 meters per second, which I assumed earlier, and I was wrong about that. The boy is not moving at a constant speed of 3.5 meters per second. The girl is moving at a constant speed of 3.5 meters per second. The boy would accelerate up to 5.6 meters per second and then maintain constant velocity. So I was a bit slightly wrong over here, but this idea is equally applicable in this case as well. But before I get into the power equation, I'm trying to give you the force scenario. Try to appreciate the force scenario. The boy is supposed to have a resultant force in the forward direction that is supposed to be how much? Let's say the resultant I'm going to show by sort of rainbow color. So let's say that this resultant is supposed to be how much? Resultant is supposed to be mass into acceleration. This is the total force that you are trying to look for. This resultant force should come from the subtraction of two forces. One is the forward force produced by his own muscles and chemical energy, minus the backward force due to the friction and the internal friction of the system and the air resistance. So if you do subtract these two, the reason I'm subtracting them because these two forces are working in opposite direction. That's the whole point of subtraction. In that case, we're gonna have resultant force to come out to have a certain value. এই question সবাই বুঝতেছো কিনা খেয়াল করো. If you have any question about this equation, ask me about this, please. Everyone, have a look. Does this equation make sense?
Yes, sir.
Everyone else, please comply. Write yes or no in the question. I want everyone to comply whether this equation makes sense to you or not.
স্যার বুঝতে তো সমস্যা হবে ন্যাচারালি।
Yes.
স্যার এটা কি কাইনেম্যাটিক্স চ্যাপ্টার এ স্যার?
Yes, chapter number 2.
স্যার আগের চ্যাপ্টারটা কি ছিল? আচ্ছা এটা থাক থাক। মানে আপনি যে
Let's talk about the earlier chapter after the class. No problem. I'll update you. ঠিক আছে?
ঠিক আছে।
Don't worry. So M equals to resultant force, which is equals to force in the forward direction minus 23 Newton. So এখান থেকে আমাদের এই ভ্যালুটা আসবে. So you can essentially find that. How much was the force that was essentially produced by this kid that should be given you by resultant force plus 23 Newton. So you can calculate this out. What was your answer for D1?
75.
This was 75 exactly?
Yes, 75.
Okay. So I can write over here that the resultant force required is 75 Newton plus 23 Newton is somewhere over here. So essentially you get how much force? 88 Newton. So this is the forward force that the kid is going to require to make the acceleration forward. Now the instantaneous power is supposed to be this forward force into the velocity of that instant. So that should be 88 multiplied by 3.5, whatever the power that you get, that many watt. Bolo.
It's 98 and the velocity is 4.5.
Really?
Yeah, the question, like the D2, it says at a speed of 4.5 meters per second.
Okay. I'll change immediately because I can. So this is supposed to be 98 and this is supposed to be 98 into 4.5. Okay. Beats me. দেখো বুঝা গেছে কিনা I really did some mess up in the process of the description, but then I tried to cover it up for it because I didn't read the question well. I shouldn't have rushed through the process. I should have read the question properly. This is something that I always do. I don't know why I skipped this in for this question, and I am paying the price for it. I had to do some two correction revisions. Anyway, my bad. But are we clear with this now, everyone?
Sir, I had a question. Like,
Yes,
sir,
go
আমার
ahead.
ইন্টারনেটে প্রবলেম করছিল তো আমি বুঝতে পারিনি যে এখানে আমরা ফোর্স ইনটু ভেলোসিটির জায়গায় ফোর্স ইনটু ডিসটেন্স বাই টাইম করলে সমস্যা কেন হতো?
কোনো সমস্যা হতো না।
আমি ফোর্স ইনটু ডিসটেন্স বাই টাইম করেছি আর আমার অ্যানসারটা মেইন অ্যানসারের হাফ আসছে।
How much force did you use?
75 plus 23 যত আসে।
And how much was your distance?
ডিসটেন্সটা হচ্ছে s equals to u plus v divide by 2 into t ওই ফর্মুলাটা ইউজ করছি।
That is something that you cannot do. I'll tell you why. Because the question was asking you to find out the instantaneous power at this instant, not the average power. S equals to u plus v divided by 2 is applicable for the total distance span, where a u plus v divided by 2 is basically the average velocity. So what you did calculate is what was his average power developed in the entire duration of the acceleration. That's what you did calculate. The question is not asking for the average power at this speed. Get this word. At this speed, not over the duration of the acceleration. These are two different terms. Now, if I wonder, what does that even mean? Let me elaborate. When the boy is going to start accelerating from 0 speed, he would have a very minimal air resistance. As he's going to slowly speed up faster, then the air resistance is also going to increase. Do you agree?
Yes, sir.
So essentially, he would not have to produce the exactly same amount of force for the entire journey of his acceleration. He would have to exert forward force that is slightly smaller at the beginning, because he would have to overcome much less amount of air resistance. But as he speeds up, the air resistance is going to become slowly bigger and bigger and bigger. So his produced force to maintain that uniform acceleration would also have to become bigger, so that the subtraction result is same. So the resultant force is always equal to 98 Newton. How much was this? 75 Newton. So the resultant force is always equal to 75 Newton. So that's the way the force is going to change coming out of the boy's body or legs. This question is asking you to calculate the exact power required at that instant of speed of 4.5 meter per second, not for the entire duration of acceleration. What you did calculate out was for the average velocity. Do you get my point? S equals to u plus v divided by 2 into tj equation. We have the u plus v divided by 2 part. That essentially gives us what? Average velocity. So you calculated the total power developed over the entire duration of the acceleration. Do I make sense?
Yes, sir.
Clear হয়েছে কিনা?
বুঝছি স্যার।
Beautiful.
স্যার ইনস্ট্যান্টিনিয়াস যদি লেখা থাকে তাহলে আমরা ডিসপ্লেসমেন্ট ইউজই করতে পারবো না।
হ্যাঁ, আমার ইনস্ট্যান্টেনিয়াস হলেও ডিসপ্লেসমেন্ট দিয়ে করতে পারবো। আইডিয়াটা হচ্ছে কিরকম বুঝাই। The idea is very simple. Try to visualize something. If I don't draw this, if you try to measure the acceleration of, let me just draw this. No big deal. I can, because I have a lot of space, and why not? Let's say you have an object that has a VT graph that is slightly variable. Let's say I really like this color, so I'm not switching. I really like this variable color. It looks good. So let's say you have a curvature graph for the VT graph of a certain object. Okay. If you're asked to calculate the acceleration of this object at any point, do you have to essentially go for the average acceleration, or can you calculate the acceleration at a very specific point? Can you calculate the acceleration at a very specific point? You actually can. How do you do that? We draw a tangent, right?
Yes, sir.
Yeah.
Drawing a tangent doesn't necessarily mean that the object is actually following that tangent. It means that we are extending out that specific point's behavior into a line so that we can effectively measure it easily. So multiplying, calculating out this equation by doing 98 into 4.5, 98 into 4.5 divided by 1 second would not be wrong in terms of the idea or theoretical idea, but that we're assuming that if the boy did maintain this speed for 1 second, if he did do that, then he would have gone 4.5 meter within 1 second further. So this is something like this. So if I try to show you this thing in terms of force versus time graph, let's say force versus velocity graph, as the velocity increases, the force increases exponentially, because there is always an intercept. So you need, let's say this is the forward force value. So when the velocity was 0, the forward force record was 0. Now, then the forward force record was 98 Newton. He's going to require a fixed amount of 98 না 75 Newton all through. So এখান থেকে আমাদের এই ফোর্সটা মনে করো হচ্ছে এরকম একটা শেপে বাড়বে. That's how this force is going to work out. Because the faster you move, you're going to have greater increase of air resistance, because air resistance comes from two factors: how fast you hit the air molecules, and also how many air particles do you hit every second. So if you go faster, you're going to be having an exponential increase in air resistance, not a linear increase in air resistance. এই পয়েন্টে বুঝাচ্ছে?
Yes,
if you have question, please stop me or ask me questions in between, or you can raise hand. I'm looking at
গ্রাফটা বুঝি নাই।
What I mean is that air resistance of an object does not essentially increase linearly with velocity. It increases exponentially with velocity. The reason is that, the way air resistance work, try to think about it. How does air resistance essentially work? As any object passes through air particles, he has to push out the air particles out of its own way to make itself go through the atmosphere. Now, if an object is moving slowly, he's gonna collide with individual air molecules with a lower speed. So the individual air molecules would have less momentum change, and they're gonna exert a smaller force. Individual air particle will exert a smaller force onto this body surface. And because he's moving slowly, he would be colliding with fewer number of particles. Compared to if you increase the speed of an object, if your object is moving pretty fast, then the individual collision of the air particles would be higher, would give you a bigger amount of opposite force by Newton's third law. And the number of this collision per second would also become higher because you're now moving through a much longer length of the atmosphere. So two factors work additively together. So it's not that whenever, so it's not one single factor. That's why whenever the object speeds up, the resistive force or air resistance increases exponentially, not additively. Geometrically, it increases geometrically. I can use that term as well. বুঝতে পারছি?
বুঝছি, বাট y axis y axis 0 দিয়ে শুরু হয় না কেন?
Because I'm trying to show you the forward force produced by the kid over here. When the velocity was 0, the kid was still accelerating, because you have to understand, according to the description of the graph, the kid did start to accelerate at t equals to 0. এখান থেকে সে accelerate করা শুরু করছে না? Now he is going to maintain an uniform acceleration of something over here up to till the point he reaches 5.6 meter per second. That's the whole point. So from t equals to 0, বুঝছো? Good. So let's say this is the forward force value of, let's say, 98 Newton. Now if you want to measure the power of this 98 Newton force, what we are saying over what you're telling over here, that other than exactly measuring, maintaining the object at 98 meter per second, we could actually draw a tangent of this curve and assuming that this kid assuming that this kid maintain this velocity for this thing, and we can essentially measure the gradient of this graph. I'm using the term of the gradient because I'm trying to give you the idea of expanding the information of a point of time into relevant and logical amount of duration without changing the other variables. In true case, as the boy moves forward, he's definitely gonna speed up and he's gonna experience different values of force, which is obviously true. But if we want to calculate the instantaneous power at a certain speed value of the boy, we can multiply the forward force and the instantaneous speed of the boy to get that number. That's very much possible for us to achieve. বুঝতে পারছি?
Yes, sir.
ফারহান বুঝা গেছে?
জি স্যার।
আচ্ছা। Anyone else? Do you have any question? Or did it make sense altogether at the end? Okay, I'm hoping that you don't have any question. তারপর 12, 13. $14. 14 is similar stuff. You have to use the, you can see over here, they have already mentioned the U over here. So you just go ahead with this one. Any of the part of the kinematics chapter, this kind of nucleus cases that might ask you some question about the nuclear process itself, you can skip them for the time being if it's not covered, if it was not covered in your O-level syllabus radioactivity chapter, because we're going to essentially do the radioactivity and nuclear chapter pretty much as at the last chapter of our syllabus, which I always do it that way, and the syllabus also places it at the end of the syllabus. So so all the theories and the relevant additional stuff that you're supposed to know from the chapter of radioactivity will be taught to you pretty late. But because the ideas are pretty much mingled, because it's physics altogether, so they might give you some nuclear, along with the momentum question of this chapter of the collision idea, and they might also add some nuclear question just to fuzzy up the whole question aspect. So that's possible. So if you ever come across this kind of question, you can just write later beside this question, meaning that we're gonna try and do those questions once we have finished our nuclear physics chapter. So no big deal there. 15, any question from 15? Could you draw this vector diagram properly, everyone? Sixteen. Problem bolo. $17. Do you guys know why this expression? Could you do this derivation of this question, that how this EKB equals to P square by 2m comes by?
Yes, sir.
Did they show you this in a lecture? I think this was included in the lecture.
Yes, sir.
Yeah.
It was.
Good. Didn't forget the important stuffs. 16, 18.
Sir, 18.
18
B1.
B1.
B1 and 2.
Acha. I'm going to read it through from the beginning so that I don't miss out something. Complete figure 2.1 to show whether each of these quantities is listed is a vector or a scalar. Okay, that doesn't sound bad. Distance moved is scalar, speed scalar, acceleration vector. Wow. You see, the paper 2 is not that hard. I mean, there are questions which are called guessing questions or stupid questions to be memorized, and there are also questions which are called square counting graph calculation, and then there is this question. Look at it. So it's not all bad. It's compensating to some extent. How much time do you think would you require to, do you require to answer this question and score 3 out of 3? 5 to 10 seconds? No, not 2 seconds, because to write the whole word you require more than 1 second. So maximum 10 seconds, I think.
Yes, sir.
If you're not really dumb, like really dumb. Being dumb is not a problem, by the way, kids. If you don't think this word personally onto any of you, I'm using this word in the sense that, I mean, the whole point of being successful, unsuccessful, dumb or smart is all about, it ultimately weighs up in that how much stubborn you want to be to solve the problem, how much tenacious you want to be to solve the problem, how much perseverant you want to be to solve the problem. That makes all the difference. You don't have to be talented to be successful. You have to be hardworking to be successful. Talented people might get a little bit of edge off from the hardworking volume, but without hardworking, no one can be successful, period. So dumb is a pretty simple word to use in this aspect, that people who do not do hard work are dumb because they don't understand the significance of it. Not that their brain doesn't work properly. Dumb is not used in my lecture or in my classes in that general manner. B number. A ball falls vertically from in air from rest. The variation with time t of the distance d moved by the ball is shown figure 2.2. So this is a DT graph. Looks pretty good. I'm gonna go by the property of this graph a little bit. Then I'm gonna go into the calculation. Have a look. We have a DT graph, and you can see that the initial part of the graph is starting tangent with the x-axis. So I would say the initial gradient of the DT graph is 0, which tells us that the object was dropped from rest. That's all. That's something also mentioned in the question as well. Drop from the rest means initial velocity is supposed to be 0, so which means the initial gradient of the DT graph is supposed to be 0, which means the graph should start apparently horizontal from the 0-second mark, which is happening here, and then the axis again, then the velocity is increasing because the gradient of the graph is increasing, and somewhere over here I think the velocity became constant somewhat, but we're gonna find that out in a bit. Okay. Problem কোনটা বলছিলা সাদিয়া?
স্যার না আমি ভুল বলেছি, আমি ভুল নাম্বার বলেছি।
আচ্ছা, সো এটাতে প্রবলেম নাই?
নো স্যার।
আচ্ছা, ওকে, নো প্রবলেম, ইটস ওকে। 19 এর প্রবলেম, এই যে এইটাতে প্রবলেম, এটাতে প্রবলেম আছে? আচ্ছা এটাতে প্রবলেম আসে বা নাই whatever, I'm going to discuss these questions anyway because I do it every year because there's some pretty important stuff for you to consider at this question. Take a look. The distance is moved by an object at time t may be given by the expression s equals to half it square. Come to think about it. What do you think this which equation do you think that this expression is derived from? We had 4 equations of motion. From which of those equation does this come from?
S equals to ut plus half it squared.
S equals to ut plus half it square, exactly. But do you see the ut part?
It starts from rest.
It starts from rest, but the question already says that. No.
No, sir.
These are the 2 conditions that you are supposed to write. The state 2 conditions for this expression to apply to the motion of an object. Condition number 1, the object starts from rest. Or you can write this whole paragraph, or you can simply write initial velocity equals to 0. Those 3 words, initial velocity 0, scores you the mark as well. Number 2, the object moves with uniform acceleration throughout the time. That's important for those equations as well. I told you at the very beginning that those 4 equations of motion, v equals to u plus at, s equals to u plus v divided by 2 into t, s equals to ut plus half t square, and the 4th one, v square equals to u square plus twice s. All 4 of these equations are applicable for uniform acceleration cases, which means you cannot work with them if your object is having some sort of non-uniform movement. That's not going to work out. So that's your second expression. So B number. A student takes a photograph of a steel ball of radius 5.0 centimeter as it falls from rest. The image of the ball is blurred as illustrated in figure 2.1. The image is blurred because of the ball because the ball is moving while the photograph is being taken. এই কথাটা খুব important. The image is blurred because the ball is moving while the photograph is being taken. What do you mean by the word? What do you understand by these 2 words? Being taken. What do you mean by that? Come on, give me
The
expressions.
ball was moving when the photographer took the photo.
So being taken would essentially mean which part of the duration in the photograph taking process?
ক্যামেরার বাটন ক্লিক করা আর প্রসেস হওয়া।
Not essentially, but it's a part of the process, but not essentially that. I'm looking for a bit more specific.
The ball was still in motion while the photograph was being taken.
Yeah, that's exactly what it says. You just read the question. I want you to tell me what this means.
Takes time to take the photo, and while the time is going, the ball moves a specific distance.
Yeah, so why do we have a blur? Why don't we have a single image? I'll
The
tell you
ball
this.
was moving.
কারণ বল থেকে যে লাইটটা রিফ্লেক্ট করে ক্যামেরার ফিল্মে পড়ছে, তো ফিল্মটাকে পুরোপুরি রেজিস্টার করতে করতে একটু টাইম লাগে, এই টাইমের মধ্যে কিছু একটা হয়।
Yeah, what Zarif just said, exactly that one. But I'm gonna add one more word to the description, which is not relevant to physics. I'm just trying to give you the idea. The way any camera works is that whenever you click the button, either by some electronic mechanism or by some mechanical mechanism, it opens up an aperture which is called a shutter. By opening the shutter, the camera mechanism allows a certain amount of light onto your film. It can be a physical celluloid film, or it can be a digital CMOS chip, which will detect the light and convert that information into the photograph. Depending on the illumination level of your object that you are trying to take the picture from, this shutter speed can be varied in manually or electronically as well. You can choose the shutter speed. The reason we are having this whole blur is because the shutter got open when the ball was over here, and the shutter remained open for as long as the ball fell from here to here. That's why there was a blur. That the shutter received the light from the ball from the top position all the way to the bottom position. When the ball was over here, then the shutter of the camera got closed, so the camera did not accept any further light as the ball went further. But this figure does not mean that the ball came to stop over here. The ball is moving for both the positions. Do I make sense?
Yes, sir.
Shutter part টুকু বুঝছো? Everyone, shutter part টা কি বুঝা গেছে?
বুঝা গেছে।
So that's the basic idea. So we're gonna go forward for how working with this thing. The question says the scale shows. Sajid, তোমার problem কোনটাতে ছিল? আচ্ছা, I'm gonna cover the whole question. The scale shows that the distance from fallen from rest by the ball at time t equals to 0 on top of the ball, the level is with 0 mark on the scale. এই সেন্টেন্সটা খুব ভালো করে খেয়াল করো। The scale shows the distance fallen from rest by the ball. So they have now telling us that the ball was starting from rest, which means we are eligible to use this equation for our math, because this equation was applicable for an object that would essentially start from rest. It says that at time t equals to 0, the top of the ball is level with the 0 mark on the scale. Which edge of the ball was level with the 0? Top of the ball. Which means for any further point of distance measurement using the ruler, you have to take reference for the upper end of the ball. So this one or this one. You cannot take the center to center. That would be wrong as per the question specification. Check this out. At time t equals to 0, the top of the ball is level with a 0 mark on the scale. Do you understand this sentence, everyone? The reference level for the ball to measure the distances using the ruler is the upper edge of the ball, not the center. Which we typically, I'm highlighting this information because typically we may always measure the distances from the center to center, but that is not the case because the question specifies it so. So then it says calculate to an approximate number of significant figures the time the ball falls before the photograph is taken. So before the photograph is taken, it is going to cover 79 centimeter. If you hold up a ruler over here, a horizontal line over here, you'll see that the top of the ball is aligned with the 79 centimeter mark. So you use 0.79 over here. You use a equals to 9.81, which is the value of gravitational acceleration for your S level altogether, and then you calculate the value of t, which is not very difficult. Then it says the time interval during which the photograph is taken, and this question has a total mark of 3. This is the point where the students make a lot of mistakes. There are two different ways to approach this problem, which I'm going to explain part by part. So keep your eyes peeled, and if you have any question, I will ask me about it. Consider the question once again, the time interval during which the photograph is taken. So we are now trying to calculate for how long the shutter was open. That's what we're trying to get at. So I might as well rub this off. The beauty of this thing is this is an infinitely big thing. I might as well set this to 100% and make this one get bigger because this doesn't break up. Okay, now I can make a little bit of a zoom out. Okay, so let's have a look for this figure. What I want you to understand clearly is that we are trying to find out how long did it take from here to here. How much is the covered distance for these 2 points? How much is this distance? Tell me. This distance equals to how much?
11 centimeter.
11 centimeter. So the common mistakes kids tend to do whenever they are not reading the question well, they directly go ahead and apply s equals to half a square because they were awarded with this equation, and do the calculate the time out of this thing and scores a big 0 out of it. Tell me why. If you directly place 11 over here, so what I'm meaning is that if you do your calculation like this, let's say 0.11, which is the meter value of the 11 centimeter, equals to half into 9.81 t squared. If you do this, you're going to score a big 0 out of it. Why?
Because when the photograph was taken, the ball didn't have zero acceleration. The zero initial velocity.
Beautiful. Velocity, yes. So this equation was exclusively applicable for the case when the ball was supposed to have zero initial velocity. So, but for this segment of motion, when the ball was at the 79 centimeter mark, was it stationary? It was not. So you cannot use this equation directly for this one. Now you might wonder, then how are we going to solve this? Well, there are two different ways you can do this thing. On the so to make sense out of what are the two different ways, I'm going to draw the whole thing a little bit roughly and show you this thing. Let's say this was the level of the ball when the ball started to move. So this was the 0 centimeter mark, let's assume. And the ball was falling. And at the 79 centimeter mark, 79 centimeter mark, our camera got opened, and at the 90 centimeter mark, figure not down to scale, just try to make sense out of my drawing. At the 90 centimeter mark, the camera shutter got off. So what you need to understand that the final velocity of this much falling is the initial velocity of this much falling. Do you agree to this one?
বুঝি নাই
Within the first 79 centimeter of fall, the ball is gonna attain a final velocity after falling through this much height. Let's say after falling this much height, the ball gets a final velocity of x. This x would be the initial velocity for this 11 centimeter. This 11 centimeter would not have a zero initial velocity because zero initial velocity was located at the highest, at the initial point of the ruler. As the ball fell through this 79 centimeter, it is gonna definitely achieve some speed. And this is a continuous fall process, which means the final velocity of the 79 centimeter is the initial velocity of the next 11 centimeter. And this can eventually go on forward, but I'm not extending this any further because we don't need that. So if you want, so one way to, let me explain it follow through completely, and then you can ask me questions. One way we can solve this problem, which is a difficult way, I'm showing you this to the difficult way first, then I'm going to show you the easier way. The difficult way to solve the problem is that you can go for v equals to u plus at, where you can find out the final velocity over here, which I labeled over here as x. So let's say this is not x, let's say this is v. So in this case, for the first segment, this u is supposed to be 0. So you can calculate 0 plus 9.81 multiplied by the time that you calculated out of the first equation. How much was the time from the first equation? Someone tell me this value. Anyone?
Sorry, 0.40.
One more digit. Anyone?
0.401.
Okay, I would appreciate to use a bit more digits. Is this different color making any problem for anyone?
No, sir.
Okay, if it's a problem for anyone, please let me know. I am kind of liking this thing, that's why I'm not switching my color. But if it's necessary, I will. Don't worry about it. Acha. So v equals to 8. So we can calculate this out, this value. This would be the yes. So this So this would be the final velocity of the first falling segment, which means we can use this value of the final velocity as our falling segment for the next part. And then you can go ahead and calculate the time it requires using this formula s equals to, in this case, I'm going to write vt plus half it square, because by using the term v over here, I'm meaning the final velocity after the first 79 centimeter of fall, which should be the initial velocity for the further 11 centimeter fall as per the question detects. So you can calculate now it properly. 0.11 equals to whatever the value you get over here. So that value into time plus half into 9.81 t square. So you're gonna get a second order equation, solve it by your calculator, and you can get the value of t. One of the values is gonna be positive, the other one is gonna be negative. Negative is unacceptable because time cannot be negative. So the positive number is your answer. So that's one way to solve the problem. But this is a typical way. The reason I'm telling you this problem is because the next way, which is the easier way, you might forget about this way in your exam, because this is one of the very simple thing that comes to our mind whenever you just look at the question. They're going for the regular formula that we are acquainted with. So this is one way to solve the problem. Are we okay with these two steps? Everyone, check this out. First, you have to find out the velocity, and then you can use the formula for the equation. Eta বুঝা গেছে সবার?
Yes, sir.
If you have any question, respond. Or we can do one more thing which can prove to be even easier. And that other thing can be, we can, other than doing this equation for this whole part, if I take this figure once again, and let's say in this case, I'm going to use one single color, so I'm going to use only red. We can write this equation s equals to half at square for two segments. We can calculate how much time it takes to fall through this much, and then we can calculate how much time does it take to fall through this much altogether. So we're can calculate these two individual time durations. because to apply, we can very easily calculate this time value by directly using this expression that we are already provided, this one. That is not a big deal for us, because for this equation was applicable for the case where the initial velocity of the object was 0, which is basically the top level of the ruler. So I can very well go by this. 0.79 equals to half. So I have actually already calculated this time, right? This time was calculated to be how much? You told me that it was 0.401 second. This is already calculated, so I don't need to do this calculation anymore. What I can do, I can calculate the total time required to fall through the entire 90 centimeters. So I can do this. 0.9 equals to half into 9.81 t squared. I can calculate this one. And then this will give me the total time required to fall the entire 90 centimeter. As a result, the time that I am asked to calculate, so I can write time for fall of 11 centimeter equals to whatever you get from here, that t value minus 0.401. Check this out if it makes sense. That is the easier way. So you are calculating two individual time durations, but both of these time durations are starting from the very initial point of the ruler. And then we are just subtracting to calculate this time. This second process is much too simpler, much less time consuming in terms of mathematical working and also thinking process. But if you forget about this process, then you can always go by the first process that I have showed you in the colorful marker writing. So I have shown you two different methods. So whichever you feel comfortable, you are comfortable with, you can adopt, no big deal. Both of them are gonna give you full marks anyway, because the question did not specify that. You have to use the given expression. The question didn't specify that. They asked you to calculate this value, so you can go by either of the ways. Yes.
Sir, can you once again explain why we cannot use the stated equation? মানে equation যেটা state করা ছিল?
মানে why can't we do this? That's your question.
No, yes sir, যে মানে first
Because this equation was applicable when the initial velocity for the s displacement is 0. But for this 11 centimeter of the fall, the initial velocity at this point, is it 0? Think.
Sir, তো আবার বলবেন।
This equation is applicable for when the object was starting with an initial velocity of 0 for the s displacement, which means for the total amount of displacement of s that you are observing. At the initial position of this s, the object should have 0 velocity, meaning initial velocity should be 0. For this 11 centimeter exclusively, at the initial position of this 11 centimeter, which is a 7 centimeter mark when the shutter got open, is the velocity of the ball 0 over here?
No.
So you cannot apply this equation directly for 11 centimeter directly. You cannot do that. For you to be able to apply this equation, you have to start from the position where the object's velocity was initially 0, which happens to be at the 0 centimeter mark. That's why I told you that we can calculate these two time instances individually, then we can separate these up to get the answer.
Okay sir, আপনি বুঝেছি।
বুঝে গেছে?
Yes sir.
Everyone else, please comply. Did the logic make sense? Respond in the chat box if you don't want to speak up. Please, everyone. All right, some of you did, some of you still don't feel like sharing your opinion. Okay. And then the C number says the student in B takes the same photograph starting at the same position on the scale. That ball has the same radius but less dense, so the error is not negligible. State and explain the changes that will occur in the photograph. Now this is a pretty important, interesting question. And the student is trying to take the same picture, but in this case the ball was less dense, so error was not negligible. So if you are trying to visualize this physically, let's say the first ball was a pool ball. Pool balls are extremely heavy and they are really smooth out. And let's say the second ball was a ping pong ball. So it was less dense, so errors are not negligible. So which means there is a significant error resistance, or the weight is not too big compared to the resistance. And the way to put that. State and explain the changes that will occur in the photograph. So what are the different changes you're going to see on the photograph? You have to mention that. And you would also have to mention why would you see that? This part is pretty simple. If air resistance is a significant force to be considered, then this lighter ball should not fall by 79 centimeter in the same amount of initial time. So the upper level should be located significantly above 79 centimeter mark. That's the first part. Because the resistance would be available, the lighter ball or less dense ball wouldn't be able to fall by this exact amount of distance. That's not going to happen. Point one. Point two, because the ball will also have a lower downward speed at the starting point of the photograph, the total covered distance for the duration of the photograph would also be less than 11 centimeter, which means this blurred region over here is going to be smaller than 11 centimeter because the ball is going to have a smaller velocity compared to the denser ball. So I'm talking about two options. Let me label them with, let's say, green over here. First observation is that the starting position of the ball should be above 17 centimeters somewhere. Let's say somewhere over here, somewhere above over here. And the total amount of gap that is seen over here, for example, for this case, the gap seen was 11 centimeter. For a lighter ball, that gap should be smaller than 11 centimeters. So if we actually do too many lines over here, I shouldn't have drawn this many lines here. My bad. So let's say this is our setup. 0. So the lighter ball should be seen above, much higher above when the photograph is starting to when the photograph is starting to be taken or shutter was pressed, and the total amount of length that it should show us for the same duration of the shutter remaining opened should be less than 11 centimeter, because the velocity would be less and it would cover less distance as it falls to the atmosphere. So these are the two logic that I can think of currently, but I'm gonna essentially show you the mark scheme and convince you of the fact, and let's see if we have to add anything else. 19. Resistance means ball speed of acceleration is less, so length of the image is shorter. So they are only mentioning one reason and one answer. I actually gave you two different things. Okay. Okay, I think I was wrong in reading the question. I'll let you read the question again. A second student takes the second photograph starting at the same position. Oh, yes. Read the first sentence. I did not read this properly. What does the first sentence read? Read this. Make sense out of it. What does it read? What does it mean?
The upper level would
79 সেন্টিমিটারের ক্যামেরা অন করছে।
Exactly. Second camera was also turned on when the ball reached the 79 centimeter mark. So the first point that I just told you, that if the ball should be observed at higher than 79 centimeter mark, that is not applicable because the question didn't specify that. So you have to only talk about the length of the blur. That the length of the blur would be shorter because the ball would be falling with less speed and air resistance would decelerate, make less acceleration. AJ, means ball speed or acceleration is less and length of the image is shorter, or you can add the length of the blur is shorter, which also works out. Have a look at the examiner's report, pretty big one, obviously. The majority of the candidates were able to score at least 1 mark for stating that the air resistance would cause the acceleration or the velocity would be less than before. Poor answer suggested that the ball would be made to slow down, decelerate, or reach terminal velocity. This is something you cannot specify because you do not know how much is the air resistance compared to the weight. It only says that this new ball is less dense than the earlier, but you don't have numerical values to specify that the ball would reach terminal velocity. How much height is required to fall to reach terminal velocity, that is something that you could not calculate out of this question. So this was a poor response. Many did not refer to the changes in the photograph except to comment on the clarity of the pictures. So length of the photograph, so change of the photograph bolte hobe, clarity of the picture bolte what they are meaning is that, I mean, many students assume that this blur that we are seeing is a fault of the picture, which actually it is not. It is a default property of the picture. But many students say that the taken image would be clearer. But that is a vague statement because that doesn't necessarily specify what is the exact difference that will be seen in the first and the second figure. Then it says a significant minority referred to the effect on the time to fall the full distance rather than the section of the photograph and then consider that position of the ball when the photograph was taken had changed. So this is the error that I was going for. This is the error that I was making in the first place. Then the last sentence, many of these candidates had apparently failed to read the question carefully. Yeah, I failed to read the question carefully as well. So lots of typical and traditional problems that you can see over here. I would highly recommend that you star mark this question. You would require a lot of revision of this one, especially this examiner's report is a very, very good resource. If not for anything, to alert you of your shortcomings. So I'd appreciate that if you star mark these words. But বুঝা গেছে কি সবার properly? It's a 2-mark question, but it's full of a lot of information. Bulman, we'll move on. 22 কোনো problem? 21 কোনো problem? আচ্ছা 22 এখানে একটা গ্রাফ আছে। এই গ্রাফটা কি আঁকতে পারছো? এই ফিগার ড্রয়িংটাকে সবাই করতে পারছো? I would like to show you this drawing. I want to select the drawing. ড্রয়িংটা আমার একটু দেখানো লাগবে, দেখাবো আমি। Okay, let's have a look at the question first and then we're going to talk about it. The idea is very simple. The ball was thrown horizontally from the top of a building as shown. So it's falling to over here. It was at x distance when it was making an angle of 60 degrees with the horizontal as it is falling downwards. And then the question follows blah, 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 blah. You can try this out on your own and shouldn't be difficult. B number says the path of the ball in A, which is with an initial horizontal speed of 8.2 meters per second, is shown again in figure 2.2. On figure 2.2, it means on this exact figure, sketch the new path of the ball for the ball having an initial speed of number 1 greater than 8.2 meters per second and with negligible air resistance, label this path G, and equal to 8.2 meters per second but with air resistance, label this path A. So we're going to do two different pathways. One is for greater speed and then is for air resistance, path G and A. Now, before I go ahead and write this in, draw this up, there are a couple of information that I need to inform you. First of all, for both of these two cases, and also for the given case, the ball was rolling onto the surface, and it eventually started its journey as it was going over this ledge, which means initial velocity of the ball is always horizontal. In other words, it means that if you are trying to draw multiple trajectories for different balls to fall through, all of these trajectories should start tangent with the initial direction. So they should start rubbing with this curve. What do I mean by this? Let me show you. I might as well show you this thing on the MS Pen because I'm good with drawing curves over here using the stuffs that we have available. So the first one that it should be with greater air resistance might as well look like this. Let's say I'm going to draw this with red. So starting from the same position but falling at a further height where the initial velocity should still be horizontal and the curve should be similar looking, but it should be physically shown to have a horizontal start, not like this and not like this. You cannot have specific angle. So let's say, yeah, okay, I'm cool with this one. Kids, দেখো এই শেপটা কি বোঝা যাচ্ছে? This should be labeled greater speed G. And the next one, let me try that with green. Same stuff, but it's gonna fall closer. How much closer really doesn't matter because this is a sketch drawing. Initial should still be horizontal, so I'm gonna make this thing horizontal and then take another point and shape this out. আমি এটা নিয়ে খুব একটা হ্যাপি না। বলো তো কেন হ্যাপি না? The initial plan has a gradient. Do you see that? Have a look.
Yes, sir. Yes.
So I'm not really happy about this. So I'm gonna get rid of this one. Drawing graphs properly is a very big deal. because you have to know exactly what are the points based upon which examiners are going to mark you. Once you know those points, drawing becomes easier. If you know what you're going to judge upon, you can perform well. So in this case, the examiners are going to judge you upon two things. Number one, G would be altogether on the right side of the dotted line, and the A would be altogether on the left side of the dotted line. A would land at a closer distance, G would land at a further distance. Both the graphs would be horizontal at the beginning. এগুলো হচ্ছে observation points. How well do you draw this curve is not a big deal, because you're not necessarily plotting the points. You're hand drawing the shape of the curve. So you will not be marked up on this thing. Then again, you cannot make this, you cannot make this G graph become vertical at the end. What I mean is that this G graph, which is the greater speed curve, cannot be shown to become like this. This would be wrong. For example, say a really large gradient, and then if you show it something like this, you're showing initial gradient 0, but then again you are showing the falling on the ground is nearly vertical. This would be wrong as well. Why is this wrong? Because this is showing that the horizontal velocity component is becoming what?
Yeah.
Reduced. But that's not the case, because G was supposed to be the scenario where you have a greater initial velocity but no air resistance yet. So this would be wrong. So be careful about the endpoint gradient as well. However, A can be drawn to be vertical, nearly vertical, because in this case air resistance was there, so they don't mention how heavy was this ball. So if it's a ping pong ball, if you throw over a significantly large, long over range, it is possible that it is going to lose all of its horizontal velocity. It's possible, but G cannot be vertical. বুঝাচ্ছে কি বলতেছে? Pulaman,
Yes, sir.
everyone please respond. Do you all get the points of this graph that I just discussed?
Yes, sir.
So altogether, I have 3, 4, 5, 6 out of 25 responding. 7. Okay, 8, 9. Now more are coming by. Once I start counting, people start to pop up. Good. I'm not trying to bother you kids by asking you to give me some response. There's a reason I'm making you this, putting you through this trouble. When I physically do the class, I can sort of make sense by looking at every people's face that how much of this idea is passing across. And then I can pick up the kids who have a question mark in their faces, and then I can ask them that what is the part that you didn't understand, which works out. But in a virtual class, and because I do not like to take webcam views, because I personally feel having all the people's webcam on is a distraction for everyone. Let's say I'm taking a class of 25 people over here. If I had 25 webcam on over here, you can also on these up. I wouldn't know that whether you're keeping them turned on or not in your own device. And you might as well be looking at one of your friends who is doing some special weird stuff other than looking at my lecture. That's the continuous source of distraction. So I do not prefer to have my webcams on. Different people have different organizations have different preferences, but that's my preference. So it's important that you give me some responses whenever I demand some, so that I can at least move on. Otherwise, I'm not at peace to move on. Okay, 21 no problem. Anyone? 21, 22, 23, 24. এই গ্রাফটা আঁকতে পারছো সবাই?
স্যার গ্রাফটা আঁকিনি।
তাহলে এই গ্রাফটা আঁকে দেন তো একটু।
এই গ্রাফ, আচ্ছা, ভ্যালুগুলো ক্যালকুলেট করা থাকলে গ্রাফ আঁকা খুব সহজ। ভ্যালুগুলোকে সব ক্যালকুলেট করা আছে?
স্যার
আচ্ছা, let's assume ভ্যালুগুলো ক্যালকুলেট করা আছে. If you didn't do this, we're going to pick up those values from the mark scheme. So some of you have access to the mark scheme and give me these numbers. Or I will have the value from the mark schemes, don't worry. So might as well draw this on paint, because it's easier for me to draw there and easier for me to write on the right pad. You see, I'm adding more equipment to my arsenal. It feels good. Actually, I didn't want to. Sohail sir pushed me in the process. He's awesome. How many of you know Sohail sir? Many of you may.
I do.
Okay. As per this question says that there was a person who somehow got in the sea, and there is a rescuer coming to rescue them, and they are both lashed onto the rescue cable. They are initially accelerated for a small duration of time to give them an uniform velocity of 2.0 meter per second, which they're gonna run upwards. And then as they reach closer to the helicopter, they are once again gonna be decelerated because we don't want their heads to be crushed colliding with the helicopter. So there's going to be a small acceleration duration from the sea surface to the 2 meter per second, which is supposed to have an acceleration value of 0.50570 meter per second square. So we are going to have the time and everything. And then that uniform 2 meter per second velocity is going to run for a certain duration as the cable is winded up in the motor. And then as they reach close to the helicopter, that speed is going to reduce. So then they were going to have a bit of deceleration. So the graph is going to be like a trapezium like that. So we're going to draw the trapezium. As per the question, calculate the time ta kothay. D1 says calculate the time over which the man and the child are moving with uniform acceleration. Etar answer koto deowa ache? Eta hocche koto number question? 24. Eta hocche 3.5 seconds is the duration for uniform acceleration. And then B2 says D2 says moving with uniform deceleration. So the last deceleration part segment is supposed to have a duration of 6.5 seconds. This is the deceleration time. And then the question also actually provides us how long would be the uniform velocity. That has a duration. The time over which the man and the child are moving with constant velocity is 20 seconds. So the total duration of the uniform velocity is 20 seconds. So first 3.5 seconds acceleration. Then 20 seconds uniform velocity, then 6.5 seconds deceleration. So we're gonna cover this up all up. Add these numbers and see, do you get more than 35 or less than 35? 3.5 plus 6.5 plus 20. How much do you get? $3.5 plus 20 plus 6.5. How much do you get?
30.
30 meter per 30 seconds, which means you can very well accommodate this graph here. So let's do that. We're gonna have a straight line. Let me draw it with red and a bit smaller thickness. From here to 20 meter per second up to 3.5. So this is, have a look. Take a look at the graph. On the horizontal axis, 10 division has 5 seconds. So each small division represents how many seconds? Each small division represents 0.5 seconds. Take na?
Yes, sir.
Each small division represents 0.5 seconds. So we might as well count. This is 5. So this is supposed to be 2.5, 3.5. This is the 3.5 second mark. And I'm gonna get 6.5 later on. So I might as well draw the first line with a straight line option over here from 0 to 3.5 second mark. So this first line is supposed to be up to here. This is my point. So I'm gonna join from here through here. This is the first acceleration duration. Then the question says that then the uniform velocity lasts for 20 seconds, which means this is gonna be finished at 20 additional seconds. The most common mistake that the kids do at this point is that many of the kids continue this up to 20-second mark. This is wrong. It happens for a further 20 seconds, which means you're supposed to run it up to 23.5. So 23.5 is here. 22.5, 23.5 is here. This is gonna be up to here. And then from there, for a further 6.5 seconds, is gonna go down to 0. Another further 6.5 seconds would be the deceleration time. So the total time would be 30 seconds. So this would be your graph. Check this out. ভুলটা কোথায় হয় বুঝা গেছে?
স্যার
Yes.
স্যার হচ্ছে ফার্স্টে তো হচ্ছে ওরা দুজন যখন জাম্প করে প্যারাশুটিস্টের মতোই সবকিছু হয় না, মানে প্যারাশুট
They did not jump. You read the question wrong. There was a person who was stranded on the sea. This helicopter came in to rescue this person. So a rescuer came down to the cable, which is not covered in the question. Then both of them got lashed to the cable of the helicopter. Then they started their journey upwards. This question is about this upward journey from the sea for the rescuer and the stranded person, and as they are going up along the rope. This question is all about their journey vertically upwards along the rope. And because the speed values over here are pretty small, 2 meters per second, so air resistance is considered negligible.
Oh, yes, sir, I got it now.
Sure. সবার বুঝা গেছে এই গ্রাফের স্ট্রাকচারটা বুঝা গেছে সবার? দেখো ভুলটা কোথায় এটা কি বুঝা গেছে? এটা কিন্তু 20 পর্যন্ত হবে না। প্রমাণ এখানে ভুলটা করে। If they are trying to solve the question fast or not reading the question properly. So be careful about this mistake. 25, 26, 27, এইটা একটা ভালো গ্রাফ। এই গ্রাফে আগা ভেজাল আছে।
27 দেখতে দেখেন।
আচ্ছা ঠিক আছে, দেখা যাচ্ছে, don't worry. I'll read the question through to make sense with you. Have a look at the question 27. The drag force. Drag force is the other name for fluid friction. It might be water, it might be air, it might be glycerin, it might be oil, it could be anything. Fluid, something fluid. You're moving some object through a fluid, you're having a drag force. The drag force D on an object of cross-sectional area A moving with a speed V through a fluid of density rho is given by this equation. So this is a new equation that you're coming across. Don't have to bother where this equation pop up from. You're provided the equation, you're simply asked to use the equation for your calculation further. So don't bother or don't cloud your mind or judgment by assuming that where did this equation come from? This was not in our syllabus. Well, this was not in our syllabus. Hence, they provided you the formula. Had this been in your syllabus, you should know the formula. So it can happen.
Sir?
Yes.
Sir, sir, do I have to collect these papers?
Yes, they are provided in the proper location. I'll tell you everything after I stop the recording, after the class finishes.
Okay.
So keep up, no big deal. I'll update you in the process. So even though this concept is not in your syllabus, but you're given with the equation and you can simply work with it. The question reads, D equals to half C rho A V square, where C is a constant, so that C has no unit. So you're gonna simply do the homogeneity check. You know how to do that from chapter 1, and you go ahead with that. B number will say a raindrop falls vertically from rest. Assume air resistance is negligible. On figure 4.1, on figure 1.1, sketch the graph to show how the variation time t of the velocity v of the raindrop for the first 1.0 second of the motion. So first, for the first 1.0 second of the motion, they asked you to assume air resistance was negligible. So in 1.0 second, the final velocity is supposed to be 9.81 meter per second, right? Because v equals to u plus at. It starts from rest. So in the first 1 second, this is gonna be, or am I wrong? What would be the final velocity after 1.0 meter per second? Did they say g equals to 10 anywhere? Did these people say g equals to 10 anywhere? No. They did not say g equals to 10 anywhere. So you are expected to draw this graph up to 9.8 meter per second. So let's have a look at the graph and try to find out the 9.88 meter per second mark. Have a look on the y-axis. If you just have a look on the y-axis, 5 division represents 2.0. I always take values from here because this is easier for me to work with. You can have your own mechanism if you have a better mechanism to work with, but I personally find this one easier to work with. So for the first 5 division, we have 2.0. So each smallest vertical division over here represents how much? 2 divided by 5. That is 0.4 meter per second. That's the scaling of the y-axis. I might as well try to draw that for the x-axis. On the x-axis, the graph each division represents 0.1 second, because with 10 division you have 1 second. So 1 division is 0.1 second. So I'm writing this up for my own preference. So I need to find a locate 9.8 over here. So this is 8, 8.4, then 8.8, 9.2, 9.6. Halfway in this graph should be 9.8. See if it makes sense. Because this is 9.6, this is 10. How much do you want to draw for 1 second of velocity? 9.8. So this your preferred point should be this dot right over here there. So we're gonna draw a graph from here to there. দেখো এটা হয়েছে কিনা? That's the graph. That's the gain velocity for the raindrop is supposed to happen. If air resistance is considered negligible, that's one part of the graph. But there is more. Then it says calculate the velocity of the raindrop after falling 1,000 meter. So velocity of the raindrop after falling 1,000 meter. This is still falling under the regime of air resistance negligible. So you can simply go for v square equals to u square plus twice s, because you have the distance given, so you can find the final velocity. আচ্ছা, এই ক্যালকুলেশন করলে শেষ। সি নাম্বার কি বলছে খেয়াল করো। In practice, air resistance on raindrops is not negligible because there is a drag force. The drag force is given in the equation in A. State an equation relating the forces acting on the raindrop when it is falling at terminal velocity. Weight equals to drag force. The raindrop has a mass of this much and cross-section area of this much. The density of the air is this much, and the initial velocity of the raindrop is 0. The value of C is equals to 0.60. Show that the terminal velocity of the raindrop is about 7 meters per second. So we're gonna place everything over here. Only in the place of drag force D, you're gonna place the weight of the raindrop. How we're gonna place the weight of the raindrop? Have a look. The question already gives us the density of the raindrop, right? Have a look. We have the density of the raindrop over here. This is the cross-sectional area. So from the cross-sectional area, using the idea, so from the cross-sectional area, you can calculate the radius of the raindrop. Can you not? Polaman, respond.
Yes, sir.
You can calculate the radius, and then you can use the radius to find out the volume of the drop. Volume multiplied by the density will give you the mass.
Oh, we have the mass.
Where is the mass given? Oh, sorry, my bad. Mass was already given. I'm sorry, I didn't look it. So mass into G gives you the weight, which is equals to this much, and then you can simply write up the equation and do the necessary conversion to find out the velocity about 7 meters per second. So how you're gonna write this equation? After you are done calculation, you write the value of the velocity that you have calculated in a 3SF value. Someone do this calculation and get me this 3SF number.
7.33.
7.33. So first you're gonna write all this part. Always try to do a vertical line over here. Do half of a calculation on the left side, half of a calculation on the right side. That will double up your space for mathematical questions. It is always helpful up to your A2 level. So default procedure. So you should write equals to 7.33 meter per second. Then you should show approximately equals to, which is the curved equals to sign, 7 meter per second. Then bracket you write shown. Do not directly write equals to 7 meter per second shown. First, you have to mention the calculated value, and then you say it is approximately, because they say about. So you should write the appropriate value, and then you should show that this is nearly close to 7. So that's the procedure that we're gonna follow. Number 2 says the raindrop reaches terminal velocity after falling approximately 10 meters. On figure 1.1, sketch the variation with time t of the velocity v for the raindrop. The sketch should include the first 5 seconds of the motion. Now, this is the difficult part where we have to do some guessing. I'll tell you why. The raindrop reaches terminal velocity after falling approximately 10 meters. How much? 10 meters. On figure 1.1, sketch the variation with time t of the velocity of the v of the raindrop. The sketch should include the first 5 seconds of the motion. 5 seconds of the motion মানে হচ্ছে আমাদের এই গ্রাফের all the way up to the right point পর্যন্ত আমাদের এই গ্রাফটা আঁকতে হবে। Now, here is the deal. Before I get into drawing this graph, I would like to show you something over here. If air resistance is a significant force, essentially that would mean that our graph is supposed to be a curve. It should start with 9.8 meter per second square acceleration, which is the same tangent over here. And then it's gonna curve downwards as we have learned for the parachutist graph, and somewhere over here it should reach terminal velocity. As per the question, this terminal velocity is supposed to be 7.33, and on the graph you're gonna plot 7.33. Do not plot 7.0. If you could calculate this number, এই কথাটা খুব ভালো করে খেয়াল করো. If you could show this one, you should preferably draw your graph to represent 7.33. If you could not solve this one, then you are allowed to draw it up to 7.0. That's the whole point of mentioning this thing. They could have simply asked you, calculate the terminal velocity of the raindrop. In that case, different people might get different number, and in the graph, everyone should be subject to an ECF. They didn't want this to happen. That's why they have already told you that show that this is about this much, so that anyone who messes up the calculation can still do the graph with the 7 meter per second mark. Do you get my point? If you do the calculation, you better show your graph up to 7.33. That's the actual value. If you could not solve this or messed up this calculation, you are allowed to show the graph up to a terminal velocity of 7 meters per second. So that most of the graphs has a similar upper level limit. That's why they have mentioned you this value and asked you to do a show working, not calculate working. Moving on. What the question says that the airdrop reaches terminal velocity after falling of approximately 10 meters, which means, let's say this is the curve that you're trying to draw, where the horizontal level is supposed to be at 7.33 meter per second level, and the point where the curve becomes straight line, let's say up to this much. As per the question, this area is supposed to be 10 meter. এই ইনফরমেশনটুকু আগে ভালো করে বুঝো। The area under the VT graph for the curvature of the part of the graph, this is supposed to be how much? 10 meter. Now, can you actually calculate, I mean, is it worth the effort to calculate how much this curve area is and then eventually go ahead for the graph? Is it going to be worth it? The answer is a solid no. So we're going to do some estimation, and I'm going to show you how to do that estimation in a bit. But do all of us understand the idea of this question, what I'm trying to show over here?
The mark scheme says we should keep it to 7 meters per second.
It does?
Yeah. I first drew it to 7.33 and then I was like, then I looked at the mark scheme and it changed it.
কত নম্বর ছিল এটা?
27.
Line from 0 to curvature to the horizontal line of velocity 7 meters per second. Line which is 7 meters per second between number 5 and 7.5. Okay. The majority of the sketches were incorrect. The initial position that was meant to be smooth curve with a gradually decreasing gradient was often poorly drawn or not given straight line. The horizontal section was frequently not drawn as 7 meters per second. The point between the curve and the horizontal section was drawn with an abrupt change of gradient or a kink in the graph. Okay. A significant number of candidates tried to show a separate sketch in the space 5 other than follow the instruction to draw the sketch in figure 1.1. Okay. Acha. Mark scheme is asking you to draw it at that point. This is disturbing. This is not supposed to happen. How can I delete this thing? Can I delete this thing? No, I cannot delete this thing. This is not supposed to be here. This was supposed to be here. I don't know how this got cloned here. Anyway. So, acha ঠিক আছে যেহেতু মার্ক স্কিম বলছে আমাদেরকে 7 এ আঁকতে হবে. Our hands are tied. Acha. The first thing I'm going to do over here is to draw an approximate horizontal line over here at the 7 centimeter at the 7 meter per second level, because the mark scheme did said it so. But as far as my experience goes, you are supposed to follow the exact values for this thing. Achha, I'm going to look into this further. ঠিক আছে? Further আমি যেহেতু mark scheme 7 বলছি আমরা 7 থেকে আঁকতেছি. Now, the idea is that we should have the terminal velocity at the 7 centimeter per second level. So I might as well draw this up to this much. I'm not sure exactly how long this is going to be, because this is supposed to start tangent with this line and eventually make a smooth transition to a curve to horizontal over here, such that the area under the graph is about 10. Now there is a rule of thumb that you can go for. There's a small rule of thumb that you can go for. Have a look. I want to find out this coordinate. This is my aimed point that I want to calculate. From which coordinate should I start the horizontal line and the curve should finish. This is the point that I'm really interested about. Do you understand why? Because I know my starting point, I know my initial gradient, I know where this line is gonna be. All of these 3 points are known, 3 information are known to me. So I know I'm gonna have a smooth curve over here, and this curve should finish somewhere. I simply don't know this point. So this is my question mark. So to do this efficiently, what we can do, try to calculate assuming that if this was a triangle, this is not an exact calculation, this is an estimated calculation. So bear with me. If this used to be a triangle, and if the area of this triangle was supposed to be 10, try to find out the value of the time over here. Use your idea. Your height is how? 7, and your area is 10. So how much should this time be? Calculate. Half into time into 7.0 should be equals to 10. এটার ভ্যালু কত হয় দেখো? এখান থেকে টাইম কত আসে?
2.86.
কত?
2.86.
This one becomes 2.86 seconds, which means if this line was not a curve, rather a perfect straight line, then this time was supposed to be 2.86 seconds. But to be honest, this is not going to be a straight line. There is a curve, which means there'll be more area covered over here. ঠিক না? Above the triangle, the actual curve should have this this sector of graph, which means the actual time frame should be less than 2.86. If this was drawn to be a triangle, then we should have 2.86. And if you might wonder, sir, এই লজিকটা কোত্থেকে আনলেন? I'm answering your question. I am trying to get an estimate where this line should be about. Is it going to be at the 5-second mark? Is it going to be at the 1-second mark? Is it going to be at the 4-second mark? Where is it? Where is this curve is going to finish? I need to have some comprehension. That's why I considered this curve segment as a straight line and assumed and try to calculate out where this thing can be or will be if this used to be a triangle. This is not a triangle, but I'm trying to calculate out an estimated value, assuming this thing as a triangle, so that I can get some idea where this is supposed to be. So if this used to be a triangle, then the required time was supposed to be 2.86 seconds. But this is not a triangle, which means we're gonna have some additional area covered over here, which means if you consider for the red segment, let me draw it red. If you consider for the red segment, this time duration, because it's the area on the curve, should be somewhat smaller than 2.86. Check this out. So that the area of the triangle is approximately covered by the area of this red region. Do I make sense? This point's horizontal coordinate should be somewhat smaller than 2.86. How much smaller? You do not know. And you're not expected to calculate that as well. But you should not make this point go beyond 2.86. That's the important bit. So 2.86 means let's say 2.8. So 2 হচ্ছে এখানে, 3 হচ্ছে এখানে. This is 2.75. I might as well draw this before 2.75. So let's say I'm gonna draw this up to 2 seconds because I'm trying to make it slightly smaller. 2.86 will be somewhere over here that I can see very well. So I might as well try to draw this graph from 2. If you want to draw this up to 1.5, I don't think that's much of a problem. But I assume that from 2.6 to 2.86, reducing it to up to 2 is good enough. Because I assume it so this blue line is not supposed to be extended up to this much. This blue line should be extended up to only up to what? Up to that 2-second line. So this is supposed to be a straight line part. Now you are simply trying to draw a tangent with the initial acceleration and make it smoothly joined over here. So let me try and draw that tangent with another blue line, or I can draw it with a green so that I can make sense with it. So I'll be starting from the same point. This one finishes over here. Gradients are really important, so I should try to achieve that. Okay. About that. This is how your graph should look like, so that you have the initial gradient lining up with the original acceleration of free fall, and then this part should have a smooth transition. What the question said that there should not be a sudden change, that what they mean, this is supposed to be an actual curve, but your curve should not look like this. I'm showing you a wrong curve using purple. Where did that come from? I'm showing you a wrong curve using a purple. For example, what? Your curve, I mean, let's say you have shown a pretty good alignment over here, but then you made some angle over here. Check this out. If I zoom in, you can very well see that this purple line and the blue line did not merge up smoothly. Do you see it? There is an angle like this. There is an angle. Do you see that there is an angle? Pulavan, respond.
Yes, sir.
So because there is an angle over here, this would be unacceptable. You cannot have a, this is what we call a kink in the graph. So you cannot have a kink in the graph. Giving a kink in the graph would be difficult, would make you lose mark. So make a smooth transition. One of the easier way to draw this graph is basically that you put your wrist somewhere over here and try to draw in the reverse way. So start your graph from this and slowly start to make it join to become tangent and like this. I mean, drawing this graph in this direction will always help you to draw this graph more easily. I mean, it is easier to draw in this manner and finish this graph at the 0 point, other than starting from over here and finish it up at a very specific point. So these are some tricks that you might as well come across to learn this graph. Okay, I have kept you long enough beyond my time frame. Thank you very much for the additional duration of attention. I'm gonna stop the recording, and if you have more additional question, you can ask me. From next class, we'll start a new chapter. Hopefully, that will be forces and moment. Thank you very much, everyone. If you have anything anywhere else to go, you are dismissed.
Sir, I had a question.